Hi, I'm Kevin Milligan. I'm a professor of economics at the Vancouver School of Economics at the University of British Columbia. And this video looks at how to make a small multiples graph, starting right from the raw data, proceeding through how I manipulate it in Microsoft Excel, and then finally how to make the graph in Stata. So just to give a preview of where we're going with this is a small multiples graph. You can see this is daily new COVID cases. This is from yesterday. Split by province. So we have 10 provinces and 2 territories here, all on one graph. We call this a small multiples graph. I'm going to show you how I make this starting right from the raw data. When I do this, myself, I put the data in and run the program. It takes about 10 seconds to generate this now that I have the program all written. Only 10 seconds of work, but to describe everything here, it's likely going to be about a 30-minute video. We'll see if we can get it done in 30 minutes. So let's get at it. Let's start off with the data. So you can see up here, I have a website is the CBC website. This is the Canadian Broadcasting Corporation, has a coronavirus data tracker. I chose this site because I knew it was going to be updated every day, and it's a fairly responsible source, being the national broadcaster. Ideally, you would go right to the primary source for data. You might go to Statistics Canada, you might go to a provincial agency, but in this case, because it's Canada, I would have to go to like 10 different provincial health agencies and try to aggregate it myself, or watch StatsCan do the same thing. So instead, I just decided to come to CBC website and do it here. Importantly, I'm going to take note of the URL up here so I can refer people who look at my graph to the source and they can check my data. That's an important thing for transparency. You always want to document your source and ideally use primary sources, and I'm not actually doing a great job of the primary sources here. Okay, let's look at daily case count. Here it is, daily new cases, view it as table. And what we see here is it has Canada, and then it has 10 provinces, 3 territories, from May 26th back to January 25th. Now, you could, if you're fancy, like program some kind of software to web scrape this and save it to you automatically as a file. I don't do that just because I've never bothered to learn how to do that. It's a good skill. I wish I did learn how to do that. I'm just going to do this in an old-fashioned way, which is just copy paste. So here I go, Canada, all the way to January 25th. Good old Control-C on the keyboard. I'm going to go over to Excel. Let's take a new blank sheet here. And watch what happens. I plop it in there. Oh, look, when I plopped it in, check out what's happening here. It's giving me this nasty, all the data in one cell. That's because it's trying to post something as HTML. And so what you want to do is paste special. You paste special. See, there's HTML right there. We don't want that. Let's paste it as text. And there we have it. We have it, all the provinces, and we have the dates here. Now notice the dates aren't there. We'll get back to that in a minute. Here we have it. We have provinces here and we have dates here. I actually want to have this shifted around a bit. I want to have each date as a row and each province as a column. So we're going to transpose this. So let's just select all this again. It's a long bunch of data. There we are. Select the whole thing. And I'm going to do, again, paste special, or you can see right there, transpose. Transpose is going to flip it from columns to rows. So there we are. Now we have provinces as columns and the dates as rows. Now the last manipulation I'm going to make here in Excel, let's get rid of that. The last manipulation I'm going to make is, you'll notice this is today's, or the most recent data up top, and down below we have that January data. I actually want to have the newest data at the bottom and the oldest data at the top. So how do I flip everything? I suppose I could just, copy each row and paste it myself, but that would be a pain. So what I'm going to do instead is just sort it. So I'm going to sort it on something. What I'm going to sort it on, I'm just going to create an index here from 1 down to whatever. There we go. Now what did I do there? I selected the cell, and you see there's a little box right there. If you click that box, then that allows you to extend it as a series rather than just copy it down. So that's a nice way to make a series really fast. So now these rows are numbered from 1 to whatever. What I'm going to do is to select it all and just sort it so that I can reverse the order. So I go up here to data, and here's sort, and we're going to do it sort by, I guess that's column C, and I'm going to do it largest to smallest. There we go, and now we have it reversed. This is I think it was January 25th was the first date. Yeah, January 25th. Okay, let's note that. Okay, we don't care about these index numbers anymore. Let's put the date on here now. So let's do January 25th, 2020. There we have it. Now, if I just copy that down, we don't want that. Not every day is January 20th, 25th. What we're going to do is the same thing as before. You see that little tiny box there? You got to grab that, copy it down like that, and it fills it in sequence. So I have up to the last day, which was May 26th. So again, that saves me from typing in January 25th, January 26th, etc. All right, so that data now ready to go. I'm just going to close this and open up the one I have open with everything there just to make life easy. Here I have same data you saw before. A couple of notes before we're ready to leave Excel. I've labeled this tab as daily just because this is daily data. I give it a name. No spaces in the name. That's going to come up a few times. Putting spaces in things is bad form, and the reason why it's bad form is not all software can easily read things with spaces in it. Specifically, Stata is not good at that, so we're going to try to make sure we don't put anything with spaces. So that's called daily. I got rid of, if there's sheet 1, sheet 2, you want to get rid of garbage like that. It just clutters things up. So you don't want any of that. Just very clean, just daily, has the date, has the data, has what we want. Final thing here is the save as. So I'm going to save as, going to put it in some directory. An important thing about that is, again, we can see up here the file name, COVID-daily-cases, not putting any spaces in there. And furthermore, I'm going to save it somewhere. It's not going to be saved to the desktop. It's going to be saved somewhere really clean with a directory that I can remember. So C:/data/Kevin/COVID or something like that. It has to be a clean and easy directory because you're going to have to refer to that when we get to Stata to pick it up. If you put it on the desktop, as some people do, they put it on the Windows desktop, then it ends up the directory address for it is like C:/users/Windows/applications/Microsoft/Excel/whatever. And it's just a big mess. You can never find it. It's not good. You always want to save stuff in a nice, clean directory. That's not intuitive to those who are, born in the last 30 years maybe, but for those of us who remember good old MS-DOS, understanding that underlying directory structure is important because when you call stuff from Stata, you have to know where you saved it on your hard drive. Okay, so that's it. It's saved. Let me press save right there. Let's now flip over to Stata. So let me pull up Stata. Actually, let's just pull it all the way up from scratch there so we can see. No, I don't want to save it. Let's open Stata. There we go. Open it up. File, recent files, that one, file, recent file, and here it is, COVID daily cases. Get rid of the stuff we don't need. Now what I'm going to do is to walk through this Stata code. I think there's about 200 lines, 187 lines here. A lot of it is just notes, but it's still useful for everyone to see. Let's walk through it, starting right at the beginning. At the beginning of my file here, what do I have? I have information about the file, my name, my email address. Why do I have that? It's because if someone asks me for this data file, I want them to know who made it so they can get back to me. It's like, hey, Kevin Milligan, you made some crappy file here. I think you made a mistake in your do file. Here's a correction. It's very useful. I share my code all the time. You want to be responsible for your code. It gives you feedback on it from other people, which is great, and also makes you accountable for what you've done, which is a good thing. Put a little title here of what this does. I put the date on here, which I find useful. It is I've been at this for about 25 years. It's scary how often I go back and find some code I wrote in like 2005 and import a chunk of it, having the date on the code is actually useful so you know when this comes from. Okay, the next step in my program here is just boilerplate stuff that I do all the time. And so this is essentially, I always start every program with this boilerplate. I close any open logs, I set the more off so it just scrolls, clear the memory, etc. An important thing that I do very first though is this line right here, which is to set the directories. So what I have is it calls a certain program called set directories. I'll flip over to that program right now. What this program does is it sets the directories for this specific computer. Why is that important? Because sometimes I'm working on this computer, sometimes I might share this code with a co-author who's doing it on their computer, and I also have a work computer in my office at UBC that has different directory structure as well. What's useful then is I set these directories as macros so that in my main file here, coviddailycases.do, every time I call a directory to either read or write any data, that directory is called using the macros. So it's only set once here, and then every time I call those directories, it refers it through what's here in the directories file. And why that's important is if I share my do file with someone else, all they have to do is set the directories here once. They don't have to go through the code and change the directories 100 times. I do it once and I'm done. A couple other points about this. Down here at the bottom, you'll notice that I have this if c username equals Kevin. What that is doing is checking what the username on this computer is. The username here is actually Kevin Milligan. This one here, if username equals Kevin, is for I think my office computer. It has different directory names just because I have only a C drive versus I have a C and a D drive. That allows me to run this same set directories file on different computers and just have it run and set the directories according to the computer that I'm on. So that's nice. Two other quick points to make here. One is that, again, I have my working data directory set nice and clean. No desktop, no user / Windows / whatever. It's nice and clean. And secondly, note I use the forward slashes. Stata on Windows is very forgiving. You can do forward slashes, or I could go into this and change it to a backslash, and it will run just the same. But if I do the forward slash, that's actually what you need to have when you run it on a Macintosh machine, on a Mac. I don't use Macs, but my co-authors who do tell me that they thank me a lot when I put all the forward slashes in because that allows them to run these programs on their computers. And similarly, I think in Unix instances, the Stata also uses forward slashes. I can't remember. It's been a while since I ran it on Unix. But that's important, again, just to make it so someone can use your code most easily. Try to always do it using forward slashes. Okay, so that's setting directories. Let's go through what's going on here in the code. So I've set all that boilerplate up top. First thing I'm going to do is import the data. So this is fun. I've only started doing this recently. I used to take stuff from Excel and like export it to a tab delimited ASCII file and then import it as an in-sheet command in Stata. I've actually figured out you can just import directly from Excel and cut out that step altogether. So here, import space Excel using, and then I put the name of the file here. And then you specify which sheet. Remember, we named that sheet daily. And then first row here just says the first row is variable names. Let's just see what that looks like when we run it. All right, over here it ran it. Let's just see what data are in there. Let's describe. We have a date, which is a date format. Then we have each province. How many we have here? We have 100. We have 97 variables because there's 97 days we're using here. Let's take a look at the first 10 observations. Here they are from February into March. Here's Canada, Alberta, all the way over to Yukon. Looks clean. You always, when you do this input stuff, you always want to check it to make sure it makes sense, to make sure everything is clean, that there's not some part that's missing. Let's actually list the whole thing. Notice here, there's a missing data point here. Why is that? If we look back at our data, it's because I haven't put in today's data for BC yet. I just looked up. Dr. Bonnie Henry announced that today we had 9 new cases in BC, so there's 9. I'm going to save this. I'm going to run it again over here. Okay, it just ran. Let's list it. And look, there's the 9 for BC right there from May 27th. So now it's complete. We had 872 total cases in Canada today. Nice to have an 8 handle on there. First time since March, most likely. So yeah, cases are coming down across Canada. That's a wonderful thing. All right, so there we've loaded in the data. The next step is to do some manipulation of the data. You notice here again, the variable names are the provinces. We don't want to have that. We want to have the data set up where right now we have one observation for each day where the different variables are the provinces. We actually want to have a variable that is number of new cases and a different observation for each province day. So to do that, first we have to rename stuff. I'm going to do that over here using a global macro. The global macro is called geos, which is for like geographies. And I have the set of geographic 2-letter acronyms here, Canada through Yukon. And for each of them, I'm just going to rename the variable in that way. So it's going to rename it. Now I've renamed the variable. I'll show you what that looks like with the renamed variables. Now the variables are called new case Canada, new case Alberta, new case BC, new case Manitoba, all the way down to new case Yukon. Okay, that just renames it. Now I'm going to do a reshape command, because remember what the structure of this data looks like right now. Oops. Is we have every variable here is a different province for a different day. We just want to shift that around so we have each observation being a province-year combination. So that's done using the reshape command. Reshape commands are kind of tricky to get your head around. I encourage you to look it up using the help file in Stata. I won't go through it now. I'm just going to run it to show you what the result looks like. There's the reshape. And now we have a data set that has a variable called new case, a variable called province, and a variable called date. So we have, for date, February 20th, we have a different variable every province, and every province had 0 cases. So here's the last few ones. We have, May 27th. Here we have the cases for each province on that day. So here we have each observation is a year and date combination. We can check on that using duplicates. We have no duplicates in here, so that means that's good. Every observation is unique. That's what we want to see. We can actually do duplicates report. If I do this right, is it 7 copies for each province because there's 97 different days. So duplicates report prov and date. Oops, not data. Oh, it's not called date. What's it called? Oh, it's capital D date. There we have it. So we have no duplicates. It means we have no surplus. Everything's clean, exactly the data structure that I thought I have. It's always nice when you reshape to do the duplicates report to make sure everything appears as we wanted. Okay, next step here is to first make a moving average, which I'm just going to take, the average, take the total of the last 7 observations, divide by 7 to do a 7-day moving average. I'm going to label it and then sort by date. So let's just do that. Why am I doing a moving average? Is because the data is a bit noisy day to day. There are weird weekly reporting patterns. So I'm going to do a 7-day moving average. We now have MA7 is the 7-day moving average. And I give that a name of the 7-day moving average here. All right, the last step here is when we're comparing across provinces, of course, there are different population sizes in different provinces. BC has about 5.1 million inhabitants. Prince Edward Island has like 150,000. And so we want to, do some comparisons on a per capita basis. So here I have population by every province. Note, I put a note here in the program where I got this data. I got it from the best source, which is Statistics Canada. This is the quarterly population projections for the most recent quarter. Grab the data here. And importantly, I put the URL right here in my code. So if in the future I want to go back and update this, or if someone else wants to try to verify what I've done here, they can see exactly where I got it. Again, that's a good practice. You put the URL right in there. Here's the populations. And then down here, I create a per capita measure. Okay, just run all that, make sure it runs. Okay, now we're into actually making the graphs. Great, this is the last step. To make the graphs, what I do is, again, have a global macro from Canada through to Yukon. And then what this does, the macro does, is it cycles through each one of these one at a time. So it says for each y in the macro geos, that means it takes first the first element, then the second element, and the third element, and it assigns that element to the local macro y. So that the global macros apply to all programs that have run. The local one only applies while this program is running. You call the global one with a $sign. You call a local one by putting it between the quotation mark, the one single quotation marks. So what this does is first going to do the case for Canada overall. And let's walk through what this does line by line. It's going to be a two-way graph. That's just a category of graph we're going to do in Stata. First thing it's going to do is a line. It's going to graph the moving average as the y-axis and date as the x-axis. For province equals y, and so y by the first run through this is going to be Canada. Second run, that's going to be Alberta. It's going to do a thick line and going to have an orange line. Second line is going to be the new case data. Remember, the MA7 is the moving average. The new case is the daily, highly fluctuating cases. Here again, same thing, but here you notice the line width rather than thick, I'm going to do medium, and line color is going to be orange, but I do this times 0.05. What that does, it just fades it a bit by a factor of 50%, and then I put the line pattern as dash. So by making the line less thick, making it less intense, and by making it dashed, it's going to kind of put it in the background because I really want to emphasize the 7-day moving average, but I also want to have the underlying data there so people can pick it out, but kind of really give a visual cue that what I think is more important is the 7-day moving average. The other thing about this is it's nice to have, you have many dimensions you can vary the lines. Here I'm using the same, well, a different shade of color, different thickness, different dash. A reason to do that is because a fairly sizable minority of the population is colorblind. If I just did like one orange and one red, they may not be able to distinguish between those. So varying, you know, the line pattern and the intensity of the line or the thickness of the line are ways that you can make your graph more readily interpretable by those folks who are colorblind. Okay, next line here, really important thing in graphs. You got to put this graph region color white in there because the default in Stata is this hideous baby blue background. Every time I see a hideous baby blue background in someone doing a Stata graph, I know that they just use defaults and don't care about their what their graphs look like. Believe me, I used to be that guy for a number of years until my co-author Tammy Sherrill showed me that I got to do this a few years ago and showed me the right way and the true path, which is to make your graph region color white and not using the bad baby blue default. Label my Y title, which is important. You could just rely on the Stata default, but I want to control that daily new cases. Okay, next thing here is another tip that I really like is to have the Y label. So here, notice I don't specify how I want the y-axis to be labeled. By not specifying, you know, the increments there, I'm going to let Stata choose the increments, which is fine, but I'm going to force it to have a certain format. Having it format 9.0 FC here, the C means comma. So if it's going to be 1000, it's going to be 1, 000. If I don't put that in there, it's just going to have 1000, which is, I guess, nice for some purposes. I like to have the comma in there, so I specify it that way. If you put, instead of 0.0 in here, you put 0.2, that would then specify 2 decimal places. And again, that's important because the Stata default is not to have, say, 2 decimal places or 0 decimal places. It will do something in there, and maybe you don't like the default. So taking control over the number of decimal places and how those numbers are displayed is important. Otherwise, you end up with ugly axis labels. Next step here is the legend. This controls the legend. I'm going to force it into one column rather than a bunch of rows. Sorry, a bunch of columns across rows. Position 11 just means it's going to be, positions are done by the clock. So this is position 11, and 11 o'clock is going to be in the top left. Ring 0 means it's the inner ring of the graph. Ring 1 puts it in the outer ring. I like it nice and tight. And then here's the time series labels I'm going to use. I'm going to put the title in there as Y again. So Y, the first run through is going to be Canada. I'm going to put that on the outer ring. I'm going to save it. Important here, I'm going to save the graph. Why is that important? I'm going to save it. It's because remember, the goal here is to make small multiples. When I get to aggregating all of these individual graphs into a small multiple, I need to know where I saved it. So I have to save it in a place where I know. And I think that's it. As opposed to doing all, I guess, 14 of these at once, I'm just going to do one right now. Let's pick final BC to do first. So let's do it for BC and see what it looks like. There it is. There's BC. Notice here where we don't have any commas in there because BC has a low 7-day moving average, but Stata chose what y-axis to do here. I specified what x-axis to put there. I only chose 3 here because I wanted to have lots of white space. That's a nice thing to have. The legend is up here in top left, which is where I told it to be at 11 on the clock. And you can see nice thick orange line. The faded dashed line is behind it. It moves a lot day to day. The moving average is a bit more smooth, which is what we wanted. Let's just change something here and you kind of see what goes on. Let's just take out, actually, let's do Quebec here. And I'll show you how that looks. So here's what Quebec looks like. For fun, let's just get rid of the fading of the color. And you can see what that looks like. Okay, let's do it for Quebec. There, now it's darker, the same color, so I didn't do the fade. That's fine, you know, the dashed line still makes it quite different. Notice over here we have the comma, which is what we wanted to see. That's what I want to change now. Let's just change that, get rid of the Y label, and just let all the Stata defaults go through. And you'll see that, let's do that, and at the same time, let's also take out the graph region color white thing. So you see how ugly that baby blue thing is. Oh, and just change something else at the same time. Let's put the position as 6 o'clock. All right, change a bunch of stuff there. You can see how some of these things move around. All right, so here we have that ugly baby blue now. We lost the comma on there because we're letting Stata choose the default, and the default is that it doesn't have the comma. And now the legend is down here at position 6 on the clock rather than up here at position 11 on the clock. All right, so that's what happens when we change the defaults back. Let's reverse those changes using good old Control Z. Put everything back. Great. All right. So let's now run that not for Quebec, but run that for all 14 places. There's Canada and Alberta. There's Quebec and Saskatchewan, Northwest Territories, Nunavut, and Yukon. There we go. Got them all done. All right, so now what we're going to do is to make the small multiples. Here the key command is grc1ledge, which is kind of ugly. Let me just pull up the help command for that. Help grc1ledge. So this is a graph combine. In Stata, there's a thing called graph combine where it allows you to make a bunch of combined graphs together. I chose a user-generated ADU package called graph combine with one legend because I want the default in Stata using the graph combine is that it puts a legend on every single one of the small multiples, which just is a repetition that I don't want to have. It takes up too much white space. So I use this graph combine with one legend to make one legend. Last thing to note here is I dump today's date into a local macro. That's what this star s underscore date is. This just tells Stata to look at today's date and dump it into the macro dd. And I'm going to put that into the graph. Why am I doing that? It's because then I don't have to, every day when I make these graphs, I don't have to go in and change the date. It just automatically loads in the date. And you can see that right here. In the title for the graph, it's daily new COVID cases : DD, where DD is whatever was dumped into this date. All right, let's do it here. Let's see what happens. it has to think about it. All right, here we are. Here's our small multiples. What do we see? We have one legend here, which is what we did with the graph combine one legend file. I should note, to get that graph combine one legend file, you just have to Google it up and you can download it from a Stata archive. So it's grc1leg is the name of the file. You can find that easily enough online. All right, so what we have here is you can see this graph. So a couple of things to point out about using the small multiples. The reason you do this is to make comparisons across things. You want to have lots of white space, so that's why I chose only 3 tick marks on the x-axis here. I did let Stata choose the y-axis. It didn't make anything too egregious here, though it's a bit weird for Northwest Territories and Yukon because it's 1122 because there's so few cases down there. Very simple labels here. Again, trying to preserve a lot of white space. Having one legend is nice. What's useful about this particular way I did it, you'll note that the y-axis is different on every province, and I did that for a reason. And the reason is that allows me to tell the story of every different province as this COVID crisis has gone through. So just pick one, Saskatchewan, the initial run-up in March, like everywhere did. They fought it down to close to 0 new cases a day. But then at the beginning of May, they started to have this outbreak in northern Saskatchewan, went up, and then they were able to push that back down to close to 0. Over in Alberta, they had the initial run-up in March, like other places. They pushed it down. Then they had a meat packing issue in southern Alberta for a couple of weeks. It ran up. It was quite serious. There were like hundreds of cases a day, and then again they were able to push that back down, and now they're back down to a couple of dozen cases a day. Quebec had the initial run-up, and they've unfortunately stayed near the top, and now have made some good progress the past couple of weeks. Ontario has its own story, and every province has its own story. And that's why I do this. As you can see the different stories here. The downside of this graph is that when you look at this, it looks like, BC is like half Quebec. But then you look, oh wait, the axis here is like a factor of 10 different between BC and Quebec. And so when you compare across them, you have to note that the y-axis is different. So a way to get around that is to impose that Stata put a common y-axis on it. And you can actually do that. Let's just do that right here. We can graph combine. If I put in y common, if I spell common correctly, there's y common. So right here I put in y common. If I do this again, it should impose a common y-axis. Yeah, here we go. It's 0, 500, 1,000 for all provinces. But now you see a problem with this is like you can't see anything going on. There's no stories to be told. You can barely see that northern Saskatchewan bump. You can't see BC's story because the magnitude here is so different across provinces. So that's a downside of doing things with a common y-axis is it does facilitate these interprovincial comparisons, but you don't get to see each province's individual story. So when I present this, when I post these graphs to Twitter, I tend to do it with both. I put both versions on there just so that each of them tells its own story. I don't think either one of them is correct. I think both of them have a story to tell, and that's why I like to put both of them on there. It depends what you want to use it for. If it's going to be doing these interprovincial comparisons, you can say, yeah, New Brunswick basically had nothing going on relative to Quebec the whole time. On the other hand, if I want to see New Brunswick's particular story, I can do it without the y common in there. The other thing I do is I do the y common, but then do it with the per capita measure, which is what I do in the end. I do it per million in small multiples. So I'm going to run all that right now and actually run the whole program from the beginning, and then we'll be done. Here we go. So it's going to run the whole thing. It's going to do each province again for using the different y-axis, and then it's going to run each province again doing the common y-axis with the cases per capita. While this is running, something else I'll note, in the final version of it, you'll note that in the corner or in the bottom left, I also put a note. The note has the source of the data, and the note also has my Twitter handle on there. I put that so that people can look up the source if they think the data look wonky in some way. I also do that with my name on there so that people can see where this came from. When I'm on Twitter and I see some kind of chart or graph, I am really hesitant to retweet something or to cite something unless I know where that came from. Because, frankly, there's a lot of junk on Twitter, and if it's some rando putting, some bad data on there, I don't want to put that into my Twitter feed. I curate my Twitter feed closely as someone who tries to be an authoritative source on data, and so I don't want to wreck that reputation by randomly retweeting bad stuff. So by putting my name on there, that puts my reputation on the line there, and also makes me accountable for it. If someone says, "Wait, where is this daily case COVID graph come from?" and they say, "Oh, it comes from this guy Kevin Milligan. Who is he?" You look me up, and you can then decide for yourself whether I'm credible, and that's up to you to decide. But it allows that kind of accountability to happen. I think that's why I put my name on things when I post them. All right, here it is. I've done narrating now. Here's the small multiples with the daily new cases per million as the common y-axis. And, again, you see BC looks fairly small relative to Quebec in terms of the magnitudes. But, the story does come out a bit with the bumps on there. If you want to see the full BC story, you can go look at the one without the common y-axis. All right, so that brings us to a close. What I've showed you here, or tried to show you here, is how I create these daily graphs using Stata. You can see it takes like 30 seconds or 20 seconds to run. Once I have everything set up, all I do every day is grab the new data, plop it into this Excel sheet, I press save, and then Stata does everything from there. I hope you've enjoyed it. Please, if you found this interesting, tell me in the comments if you have any suggestions, any data visualization hints, or any tips or tricks on Stata programming you want to share with me. Please let me know. Many of these Stata tricks that I've used here are things that I've learned from students or co-authors or colleagues over the years. And as you do this job for a couple of decades, you kind of accumulate all those tips and tricks, which is why I thought this might be useful to some people to share, as you can kind of see the tips and tricks that I use when I'm putting together something, and you can find that useful in your own research as well. So thanks a lot for watching, and have a good night.